Alright, hi year 11s, this is Mr. Lim here again, and this is another video on aqueous solutions about ionic equations. So let's get started. Alright, we're going to learn about how to write ionic equations. Okay, so let's have a look. Reactions that occur in solution can be shown in more detail as ionic equations. Right, so ionic equations identify only the specific ions or substances that are involved in the reaction. So in other words, there are certain ions that might do nothing. They are just going to be floating around in solution. And since they don't do anything, they don't take part in any reactions, you don't really need to put them into the chemical equation when you write it out. You only need the parts, the ions or the substances that are actually reacting, right? So all other ions which aren't taking part in the reaction are ignored, and those ones are called spectator ions. Right, so spectator ions are the ones that aren't involved in the reaction, and we'll have a look at what that means in a bit. Right, so there are a couple of rules for ionic equations. We're going to be focusing on a few for the precipitation reactions that you're going to start to do these with, but these are going to become more relevant when you start to do the acid-base reactions in the next topic. All right, so covalent substances are shown as molecules. Ionic solids are shown as their formula because that's the form during their reaction, whereas ions in solution are shown as ions with their relevant charges. Okay, gases are shown as molecules or atoms, and states of substances are shown as well. Right, so in this case, we're going to assume that all of these ones that we go through as examples are solutions. I should have said you should be able to see that these should say solutions, right? But when we get to other topics, you might have lead nitrate solid reacts with something. And then because you have to read what the state is, you have to take that into account when you're writing this equation. But for now, we're just going to treat all of these as solutions, right? But you need to read the question and say, okay, is it a solution? Is it a solid? Is it a gas? And then use what's in the question to help you answer it. Okay, so we'll move this across a bit and let's have a look here. So we have lead nitrate solution and sodium sulfate. So what you got to think about is that, okay, fine. In a beaker for this lead nitrate, you'd have your PBs, right? That's your lead ions. Let's go highlight these to color code them. Okay, so you would have lead ions and you would have nitrate ions floating around in solution. And if you're clever enough, you'll know why there are more nitrate ions in that solution than there are lead ions, right? You would also have another beaker, sodium sulfate, right? So you would have green and yellow ions, okay? They're in solution there, okay? So when they mix together, you're going to have a beaker full of greens, yellows, blues, and reds. And from the last video, you might remember that we have to combine those two possible combinations together. And the two possible combinations together, one of them, lead sulfate is insoluble and it will form a precipitate. So the lead sulfate is the blue and the yellow. So the blue and the yellow are going to form a little ionic solid at the bottom. Okay, so that's going to form a precipitate. And what happens to the... No, that's not the blue and the yellow. What am I talking about? That's the red and the yellow. Red and the yellow. Red and yellow. Right? The red and the yellow is going to form a precipitate. But what's going to happen to the nitrate and the sodium ions? Well, the nitrate ions and the sodium ions are just going to be floating around, doing their thing, not really changing. So they were floating around before. They're still floating around because they're soluble at the end, so therefore they're not going to be taking part in the reaction, so therefore they are they're the spectator ions. All right, so that's why they're the spectator ions, because they don't actually take part, because they're soluble at the end as well. Let's show that as a chemical reaction. So as a chemical equation, it would look something like this. So this would be PB bracket NO3 bracket 2. Hopefully you're remembering your ion formulas, right? So then you can be able to put these together reasonably quickly. Sodium sulfate would be this, okay? And these would both be aqueous because they're both solutions, right? But in reality, you would say that this is Pb2 plus aqueous plus NO3. Oops, I don't even need a 2 there. Just 1 minus aqueous plus Na plus aqueous plus SO4 2 minus aqueous. Those are the things that we're actually mixing together, right? And then what happens is that this is going to form a solid. The lead sulfate is going to form a solid, right? And some people might have shown you that, okay, then we can just put together the other two ions. But do those other two ions really go together? Because they are soluble and they're really just floating around in solution. So what they're actually going to do is just float around in solution as their separate ions. Oops, yeah, there we go. Right. So they're just going to float around in solution as their separate ions. So because they're floating around in their separate solution in their ions, they haven't really changed. And if you notice, here's, whoops, I don't want that. I want that in blue. This and this hasn't changed. And this hasn't changed form before and after the arrow. So what you can do is you can actually remove those ions from solution, right? So you can remove, sorry, not from solution, from the equation. So you can remove those ions and treat them as if they weren't there, and my erase tool is broken, right? So you can remove those ions from solution and you can just treat that as a new equation, which we'll just have to write over here. Pb2 plus SO4 2 minus, both of these are aqueous, goes to PbSO4 solid. Okay, and that would be your ionic equation for that particular reaction. So that's quite a lot of work to write out the equation, to write out the ions, and then to just write out the ionic equation at the end. So really what you should be doing is looking at the two substances beforehand. So let's just say we're looking at the sodium chloride and the silver nitrate, all right? We should be looking at these substances here, and before we even do the ionic equation, we should be thinking to ourselves, well, does anything form a precipitate? If something forms a precipitate, those are the ions that we want to include, and only those ions. So we should be able to do this in our head. We should be able to see that, okay, then, whoops, let's move this way. We should be able to see that, okay, we've got sodium chloride. The chloride here is, soluble. So when we mix the things together, so silver chloride is one of the new combinations and sodium nitrate is another combination. So we remember that sodium nitrate is insoluble, so we know that that's not going to be in the ionic equation. So we just check silver chloride. So silver chloride, chlorides, silver chloride, insoluble. So we know that silver chloride is going to be in the equation. So we have to check that before we even write anything down. And you should be able to do that in your head on the paper using the data sheet. So then we would write, okay, silver ion, Ag plus aqueous, plus chloride ion, aqueous, goes to silver chloride, solid. And that's your ionic equation. You have to be able to do this part of the solubility in your head before writing it down. Otherwise, you're going to have to go through all of this process, which is way too time consuming. Okay? All right, let's try the next one. So we have copper nitrate and sodium sulfate solutions. So remember that these should say solution over here. So copper nitrate and sodium sulfate, we know that we're going to be looking at copper sulfate and sodium nitrate. Sodium nitrate, we know, is already soluble. All right, so we're going to just look at copper sulfate. Sulfate is the negative ion, so we look at sulfates. Most sulfates are soluble, except for, well, copper is not there. So what that means is that none of the ions are going to react with each other. So if none of the ions are going to react with each other, they're just going to mix together and nothing's going to occur. They're all going to stay in solution. So what we write in that case, we write no reaction. Okay, and if you're asked for, yeah, okay, so no reaction there. Okay, cool. So let's have a look at some more examples. Okay, so let's have a look over here. So nickel to nitrate and potassium hydroxide. So we should be looking for nickel hydroxide and potassium nitrate. So we should also start to recognize that nitrate, anything that's a nitrate, is going to be soluble. So I don't even have to look at potassium nitrate. So that's going to be soluble, so I don't have to worry about that. That's not going to make a precipitate. So now we always have to look at is nickel hydroxide. So nickel hydroxide, we're looking at the hydroxide part. The hydroxide is here. Nickel hydroxide is mostly insoluble, except for these ones here. Is nickel there? No, it is not. So I can write out the nickel ion, nickel 2 plus, aqueous, because it's in solution, plus the hydroxide ion, OH minus, aqueous, goes to nickel hydroxide. Okay, so all that time you spent memorizing ions, you have to now put it to use, remembering that you'll need 2 hydroxides to go with the nickel, because there's a 1 to 2 charge. You're looking for the lowest common multiple between the two values, 1 and 2, and so therefore you have to bring that to the lowest common multiple. So you have to times the OH by 2, right? And to balance out this equation, you should put a 2 there to make sure that that's balanced. All right, let's look at the next one. Okay, sodium nitrate and silver chloride. So we should remember that sodium nitrate is going to be soluble, because it's a nitrate. It's always going to be soluble. Actually, all sodiums are soluble as well. So we only have to check silver chloride. We say silver chloride. Most chlorides are soluble except for silver chloride. So then we would say, okay, we've got the Cl minus ion. We've got the silver ion. And that's going to form silver chloride solid, because that's a precipitate. It's going to be insoluble. That's the solid there. Okay, let's have a look at the next one. Ammonium nitrate and cobalt carbonate. Okay, so we know that all nitrates are not going to be soluble, so ammonium nitrate is going to be soluble. And so we only have to look at cobalt carbonate. So we look for the carbonate. Here's the carbonate. It's in the insoluble table. So most carbonates are insoluble except for these. Is cobalt one of those? No, it is not. So therefore, we've got the carbonate ion, aqueous, remember put in states, cobalt ion, cobalt ion, put in states, going to form cobalt carbonate solid. Right. Okay, and this is the last one here, so let's go have a look at some of these. Right, so what have we got? We've got sodium iodide solution and silver ethanoate. So what we're looking at is sodium ethanoate and silver iodide. Those are the two combinations. So sodium ethanoate first. Ethanoates, all ethanoates are soluble, no exceptions. So sodium ethanoate is soluble. Also, all sodiums are soluble as well. So now we're looking at silver iodide. So we look for iodide. So iodide, here we go. Most iodides are soluble except for, here we go, silver iodide. So that's insoluble. So the I minus AQ plus silver 1 plus AQ goes to AgI solid. Okay, let's have a look at the next one. Copper sulfate and sodium carbonate. So we've got copper carbonate and sodium sulfate. Okay, so those ones there. Right, we're going to look at copper carbonate. So let's have a look at the carbonates. Here they are, carbonates. They're in the insoluble table. Most carbonates are insoluble except for, and copper is not in that list. So therefore, it's going to be, and then we have to check the sulfate. So the sodium sulfate. So we know that all sodiums are soluble, but we'll check the sulfates. Sulfates, they're in the soluble table, and sodium's not there. So yep, that's going to be soluble. So we have copper 2 plus AQ plus CO3 2 minus AQ goes to copper carbonate solid. Last one, I'm not going to talk because my voice is going. And that's how you do ionic equations. Adios.